Morning class. Welcome to Ramir TV. I am teacher Ramir and today I'm going to explain 10 selected exercises on integral and zero exponents. And take note of the direction. Simplify and express the following expressions with positive and integral exponents only. Okay, take note of this direction. Right? So let's start with the first exercises. We have, okay, number one is 2x to the power negative 2. Okay. How can we simplify this expression containing the exponents? Okay, take note that we are multiplying two quantities here. The first quantity is 2. The second quantity is this expression. Okay, so we focus on this second quantity because it is more complicated. Okay, so next step, we can copy the same base and multiply the exponents. So we have 2 times negative 2. And then, next step, okay, 2 times negative 2, it is negative 4. 2 raised to the power of negative 4. Alright. No. This is x. Sorry. That's x. Next, we have to make negative 4 as a positive exponent. We can do that by reciprocating this. Okay? So, we have to put this down as a denominator. So in that case, the exponent 4 becomes positive and it has the numerator 1. That's how to reciprocate this expression. Any expression with negative exponent. Okay. So now we are multiplying a whole number to a fraction. So we multiply the whole number directly to the numerator. So 2 times 1 is 2. And, okay, we copy the denominator. So this is the final answer. Easy, right? Number 2. Let's have 2x squared this whole quantity raised to the power of negative 2. Okay, how do we simplify that? Notice that inside the parentheses we have an expression which is purely multiplication. It has no plus or minus sign in between. So, because of that condition, we can distribute the exponent negative 2 to each factor. Okay, so we can write, okay, we can distribute negative 2 as exponent of base 2. Okay, this is the base 2 has already the negative 2 exponent. X squared, then the exponent 2 is being multiplied by negative 2. Sorry, that's great. Alright. Okay. So, notice that this exponential term has a negative exponent. So again, the same with the previous example, we have to reciprocate this one. So we put 1 as the numerator, and then we put this down as a denominator, and we have 2 squared. 2 is very possible. Okay? Times. Okay, we're doing multiplication here. Okay, x. 2 times negative 2, it is negative 4. Right. Next step. Okay, I love to simplify the algebraic expression step by step so that you can follow the steps. Okay. So next step, 1, 2 squared. That means 2 times 2. That is 4 times. This is an exponential term having a negative exponent, so we reciprocate this one. So we have 1 as the numerator, and we put this down as a denominator with positive 4 as the exponent. Okay, so it seems like we are multiplying 2 fractions here. So remember that if we multiply 2 fractions, let us multiply directly the numerators. Let us also multiply directly the denominators. Okay? Let's proceed. So 1 times 1, it is, we can remove the parentheses already. So 1 times 1 is 1. 4 times x to the power 4 is just 4 x to the power of 4. So this is the final answer. Yeah, I hope you've been enjoying watching my discussion, because I myself is enjoying. I myself am enjoying these discussions, right? Let's have number 3. Number 3. Let's have, okay, very easy, x cubed times x to the power negative. Okay. Notice that in number 3, we have the same base, but with different exponents. So for that case, we can just copy the same base and then multiply that, we add the exponents. So we have 3 plus negative 2. Okay, 3 plus negative 2, that is positive 1. If you have 1 as exponent, you can erase that 1, because it is understood that any term having no exponent is understood to have 1 as the exponent. Very, very easy. Let's have number 4. Let's have 2x squared. It is quantity being raised to the power of 3. And 3x is being raised to the power of 4. Okay. Sige ako ulit. Madali lang to. Alright. So let's focus on the numerator. Okay. Notice that this expression here is a product of 2 factors. Okay. We have 2 times x squared, 2 factors. The same with the denominator. This is also a multiplication term. No, there's no plus or minus. So you can just distribute the exponents. Okay, let's start with the numerator. Okay. Okay, by the way, class, friends, diba, any term having no exponent is understood to have 1. So as we distribute this exponent to that base 2, we are actually multiplying it to the existing exponent of a certain um, term. Okay, then x, the existing exponent of x is 2. And that this existing exponent is being multiplied by 2. That's the distribution of the exponent. And same with the denominator, 3 has 1. And it is multiplied by 4. And x is understood also to have one exponent, and 4 is being multiplied to this exponent. Alright. Let me see it because it's slowly. Yeah. Alright. Let's have the numerator. Okay. 1 times 3, it is 3. X 2 times 3, that is 6 over 3. 1 times 4, that is 4. And x, we have the base x. 1 times 4, that its exponent is 4. Okay? Okay, let's proceed. 2 cube, that means 2 times 2 times 2. That is equal to 8. X from 6, we do not know the value of this quantity, so we just write x to the power of 6. And then, in the denominator, 3 raised to the power 4, that is 3 times 3 times 3 times 3. That is equal to 81. And x is unknown, so we maintain the term x to the power of 4. Right. Notice that in the numerator, in the denominator, we have the same base. And the numbers 8 and 81, they do not have common divisor. Okay, so we maintain the fraction 81, and we copy the same base. Okay, and then we are applying the law of exponent. No, as last one about dividing two terms with the same base but with different exponents. Okay, so x. So we have to subtract the exponents, right? So 8, 81. Okay. 6 minus 4, that is that's it, no? And this looks like multiplying a fraction to a whole number. So because of that situation, we just multiply the number in the numerator and this whole quantity. So 8x squared. And then we copy the denominator. So this is the answer. Is it right? Yeah. I've been enjoying. Let's have number 4. Number 5. It's 5 already. Okay. 4x divided by y raised to the power of negative 3. Okay, this whole quantity being raised to the power of negative 2. And by the way, friends, class, if some of you are new to my channel, please don't forget to, can you take a look on this? Yeah. Don't forget to, subscribe and hit the notification bell. So get updated with my uploaded videos. Let's proceed. Right. This topic is really my favorite. It's one of my favorites. Number 5 is, okay, we have the 2y and 3. Okay. Okay, notice that inside the parentheses we have fractional, we have a rational algebraic expression. Okay, then the numerator and the denominator, uh, there are no plus and minus signs, and this one quantity is being raised to the power of -2. Okay, we can actually distribute the exponent -2 in the numerator and the denominator. Okay, so we can have 4x raised to the power of -2. And then y raised to the power of -3 is also raised to the power of -2. Okay, this is the application of a certain law of exponent. Okay, please recall that law of exponent. For today, I just apply it directly. Right? Then we can distribute -2 to each factor in the numerator. So 4 negative, okay, 1 times -2. It has 1 already here. Then x, it has 1, but it is being multiplied to -2. That's how we distribute the exponent. And then y is power -3. Okay, is being multiplied by -2. See? Or 4 times negative, okay, 4. 1 times -2, it is -2. Then x, 1 times -2, it is -2. Divided by y, -3 times -2, it is positive 6. Let's proceed. The denominator has a positive integral exponent. The problem is that the numerator has negative exponents. So we have to reciprocate each factor in the numerator. Okay, so we just copy the denominator and we reciprocate this one. So it becomes 1/4 squared times this one is also reciprocated, must be reciprocated. So 1/x squared. Okay. Okay, copy the same denominator. Okay, let us focus on the numerator. So it looks like we are multiplying two fractions. So we can directly multiply the numerators and we can also multiply directly the denominators. So special case, right? Because the numerator itself has its own fractions. Okay, the denominator is just a simple term. Right, so 1 times 1, okay, let's focus on the numerator. 1 times 1 is 1. And then, this is, okay, 4 squared. That means 4 times 4, that is 16. Okay, 16 times x squared, it is just 16x squared. Right? Proceed. Hindi pang madugtong. This numerator, it is a fractional numerator, can be expressed as dividend divided by a divisor y to the power of 6. Remember that whenever you divide a fraction by a whole number, you have to reciprocate. Or whenever you divide the fraction by a certain quantity, that quantity must be reciprocated and then you proceed to multiplication. Okay, so we have 1/16x squared times, okay, this is now reciprocated. 1 for y to the power of 6. And the final answer is 1 times 1 is 1. 16x squared times y to the power of 6. It is 16x squared y to the power of 6. That is the final answer. Yeah, I've been enjoying so far. There are still 5 items. I hope you enjoy. Okay. Let's see. Let's have number 6. Number 6. Okay. 4x squared y cubed z squared times y z squared divided by 6x cubed y z. Okay. First step, we simplify first the numerator. Okay, we are doing the pure multiplication here. For as long as there's no plus or minus signs, the main operation being done here is multiplication. So we can rearrange the terms because remember that in a multiplication process, that the factors are commutative. The order of the factors does not affect the product. Remember that. Okay, so for x squared, okay, we can write it 4 times x squared times y cubed. And it happens that y cubed has its kind. No? This is y cubed, this is y. So we can just write them together. Okay? So y and z squared. Okay, we are multiplying. Okay, z squared, it has its kind z squared. Okay, so we can attach this factor here. So z squared. All right. We copy the denominator. Right? So in the numerator we have 4 times x squared times. Alright. We are multiplying 2 terms with the same base but with different bases. So y is understood to have 1 as exponent. Okay, so y 3 plus 1, that is 4. And again we are multiplying 2 terms, 2 factors with the same base but with different exponents. So we can have z and add exponents, 2 plus 2, that is 4. Alright. To copy the same denominator. Okay. Okay, we can actually separate this number. So we can have the fraction 4/6, and then okay. Remember, notice that we have three kinds of variables. Okay, so we can have 4/6 times x squared over x cubed times y to the power of 4 times y, then z power of 4 times z. This fraction here can be reduced to the lowest term because their greatest common divisor is 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. And let us apply the law of exponent. So we copy the same base, we subtract 2 by 3. Copy the same base, y, we subtract 4 minus 1. Okay. And we copy the same base, z. Okay. 4 minus 1, that is. Okay, 4 minus 1. Let's proceed. So 2 cubed times x. 2 minus 3, that is negative 1. Then 4 minus 1, that is 3. Z exponent 4 minus 1, that is 3. Okay. Take note, friends, class, that whenever you have a single term, not only that it has, okay, it does not have exponent, then it is understood to have 1 as exponent. But in this case, we have 3 single factors here. It happens that we have exponents other than 1. But they are also understood. They are also understood to have 1 as the denominator. And the problem is we have x here with a negative exponent. So we have to reciprocate that 1. So we have 2 cubed. 2 thirds times, which is reciprocated, so it is x. It has already positive 1, and you can erase that one because it is already understood. Okay, then y cubed. Okay, there is one denominator, and we have z cubed over 1. And it looks like multiplying 4 fractions. We can directly multiply the numerators. We can also directly multiply the denominators. So 2 times 1 times y cubed and z cubed. It is 2y cubed z cubed. 3 times x times 1 times 1. The answer is 3x. And this is the final answer. Amazing. From that complicated expression, that becomes this simple algebraic expression. Let's proceed to number 7. Task 9 ABC negative 2. C is being raised to the power of negative 2. AB has 1 exponent, the same with number 9. And this whole quantity here is being raised to the power of 2. Very easy. So, the main operation used here inside the parentheses is multiplication. So length is understood to have 1 as exponent, A is understood to have 1, B 1, C as already negative 2 as the exponent. So we can have 9, 1 being multiplied to 2 because we have to distribute exponent to each factor inside the parentheses. Then A 1 times 2, B 1 times 2, C negative 2 times 2. Okay, so 9, 1 times 2 that is 2, A 1 times 2 that is 2, 1 times 2 that is 2, C negative 2 times 2 that is negative 4. Right? We are multiplying so far. No subtraction, no addition. 9 squared that is 81 times A squared times B squared. The problem with letter C, it has a negative exponent. So we have to reciprocate this. So we have to write this one as 1 over C with the positive exponent. So it looks like multiplying a whole quantity by a fraction. Remember that whenever we multiply a whole quantity by a fraction, we just multiply that quantity in the numerator. Just then copy the denominator. So we can have 81 A squared B squared times 1. The numerator then is 81 A squared B squared. And the denominator is C to the power of 1. So this is the final answer. Okay, we have 3 left. Malapit na tayo matapos. I hope you've been enjoying so far. Right? If you have, I hope you are not bored with my step-by-step solution. I'm just showing to you clearly the steps. Because if you have mastered the steps, you can skip 1 or 2 or 3 steps. You can immediately jump to the higher steps if you have already mastered the basic steps. Okay, let's proceed. Okay, the time is fine. Let's have number 8. It has, okay, 5x to the power of negative 1, and y is being raised to the power of negative 2. Z is being raised to the power of 3. This whole expression is being raised to the power of negative 2. Okay, again, the main operation used is multiplication. So 5 is understood to have 1 as exponent, x as already negative 1 as exponent, y has already negative 2 as exponent, z has already 3 as exponent. Okay. And then we have to distribute negative 2 to each term. So we have 5, 1 times negative 2, x negative 1 times negative 2, y negative 2 times negative 2, z 3 times negative 2. So 5, 1 times 2, that is negative 2. Okay. X, negative 1 times negative 2, positive 2. Y, negative 2 times negative 2, positive 4. Then z, 3 times negative 2, negative 6. Okay. 5 has a negative exponent. Let us reciprocate this. So we have 1 over 5 squared times x squared times y to the power of 4. Let us reciprocate this because it has a negative exponent. So we have 1 over z to the power of 6. Okay, let's proceed. Okay. These two factors here is understood to have one asterisk denominator. So we are multiplying four fractions here. Multiply directly the terms in the numerator. Multiply directly on the terms in the denominator. So 1 times x squared times y to the power of 4 times 1. The answer in the numerator is x squared y to the power of 4 over 5 squared. That means 5 times 5 is 25. So 25 times 1 times 1 times z to the power of 6. The answer is 25 z to the power of 6. And this is the answer. Right? Let's have number 9. Okay. Combate. We have x, y squared, z negative 1 divided by x squared, y cubed, z to the power of 4. The numerator is being raised to the power of negative 2. The denominator is being raised to the power of positive 2. Okay? So let's have the distribution of exponents in the numerator and denominator. So we have x 1 times negative 2, y 2 times negative 2, z negative 1 times negative 2. In the denominator, we have x 2 times 2, y 3 times 2, z 4 times 2. Okay. So in the numerator, we have 1 times the x. So on the factor x, we have 1 times negative 2. We have exponent negative 2. Y, okay, 2 times negative 2, negative 4. Z, negative 1 times negative 2, positive 2. Over, okay, x, 2 times 2, 4. Y, 3 times 2, that is 6. Z, 4 times 2, that is 8. I love to discuss step by step. Alright. Wow. Okay. The numerator is problematic because it has negative exponents. So we have to reciprocate x to the power of negative 2. We also have to reciprocate y raised to the power of negative 4. So the numerator will look like this. So 1 over x squared. This one becomes this. This one becomes 1 y to the power of 4 times, okay, no problem with this square. Okay, this is still numerator. Remember, this is the numerator part. And this is the denominator. X to the power of 4, y to the power of 6, z to the power of 8. Let's proceed. This square is understood to have 1 as the denominator. Multiply all the terms in the numerator. Multiply also all the terms in the denominator. And this part here is still the numerator. Do not be confused. Okay? So 1 times 1 times z squared, that is z squared. And then x squared times y to the power of 4 times 1, that is x squared y to the power of 4. Okay. And that is still the numerator. Do not be confused. Okay. Then this is the denominator of the main algebraic expression. X to the power of 4, y to the power of 6, z to the power of 4. Okay, this is the numerator. Okay. So this one is actually divided by this denominator. So we can write z squared x squared y to the power of 4 divided by x to the power of 4 y to the power of 6 z to the power of 8. Okay, very long. I'm happy, not worry. I'm still happy. Okay, let us put that here above. Okay, can you clear? Okay, still clear. Okay, z squared, then x squared, y to the power of 4. Okay, since we are dividing a fraction by a whole quantity, this whole quantity must be reciprocated and proceed to the law of multiplication. So this is the, okay, let's proceed to multiplication, and this becomes 1 over x to the power of 4, y to the power of 6, z to the power of 8. So what you have learned during your what you have learned in math during the elementary years is very, very important in this topic. Okay, let's proceed. So we have, okay, z squared times 1, that is z squared. And let us multiply directly. X squared times x to the power of 4, that is x with exponent 2 plus 4. So we can have x to the power of 6. Okay, y to the power of 4 times y to the power of 6, that is y. We add exponents, 4 plus 6, that is 10. And we have only one factor, z to the power of x. So we just write z raised to the power of 8. Alright. And it happens that we have z in the numerator and we also have z in the denominator. Can you still see? Alright. Yep, that's still see. Alright, so we can have 1 over x to the power of 6, y to the power of 10 times z squared over z8. Okay, so z squared times z to the power of 8, that can be written as z 2 minus 8. 2 minus 8, that is negative 6. Okay, and because this term has a negative exponent, we have to reciprocate. So it should be 1 over z to the power of 6. And again, we are multiplying two fractions. So 1 times 1, 1. X to the power of 6, y to the power of 10 times z to the power of 6 is just x to the power of 6, y to the power of 10, and z to the power of 6. Okay. That is the final answer. Very simplified. And let's have the last number, 10. Can you still see? Okay, number 10. Number the last number, we have x raised to the power of negative 2 plus y, and then we raise this quantity, this binomial quantity, to the power of negative Okay. In this case, this is not a pure multiplication. This is already addition, an operation of addition. So you cannot just simply multiply this exponent here to its exponent inside the parentheses. That is a violation. Okay. So we need to simplify first inside the expression inside the parentheses. So okay, since we have x raised to the power negative 2, the exponent is negative, let us reciprocate this term. So we have 1 over x squared plus y, right? This is being raised to the power negative 2. And then we are adding a fraction and a whole quantity. Let me see it because the stand would be not be slanted. Sorry, there's something like negative 2. Okay? So remember that y, because it is a single term, it has no exponent, so it is understood to have one exponent, and it is also understood to have 1 as the denominator. So what do you think is the least common multiple of these expressions inside the parentheses? It is x squared, obviously. Okay, so you can have 1x squared plus, okay. How do we make 1x squared to make them similar fractions? So you can multiply 1 by x squared. And then y, you can also multiply that one by x squared. Because take note that in a fraction, to maintain its value, whatever you multiply to the numerator must also be multiplied to the numerator. And whatever you multiply in the numerator, that must be also multiplied in the denominator. That is the rule. Whenever you simplify the fraction, or whenever you make the fraction bigger. But you can say that the fraction is still correct if its main value is consistent. Okay, let's proceed. So we have 1x squared plus, so we have x squared y. So why not y times x squared? Usually in multiplying the algebraic expressions, the order of the factors in the product must be that the letters must be alphabetical. So we write first x because it is the first letter in the alphabet, and it is followed by y. That's why it is advisable to write the exponents in alphabetical order. Okay, 1 times x squared, we have x squared negative 2. Okay, we have already similar fractions. Okay, so we can just copy the same denominator, but sadly 1 and x squared y are not similar terms. So we can just write as this. Okay, we maintain negative 2 outside. Okay. So, how do we solve this problem? You cannot readily add this negative 2 in the numerator because this is not a pure multiplication. Okay, so you can reciprocate the whole expression. So what happens is becomes 1 over 1 plus x squared y over x squared. and the exponent is already positive. Okay. The next step, uh, 1 another. Okay. So we focus on the denominator. So we have 1 plus x